Hello everybody, welcome into another lesson. So today we are going to talk about functions. And again, this may largely seem like a review to a lot of you, but this is still very important to talk about because precalculus and even higher than this are heavily functions based. So in review, a function is a relation in which each member of the domain has one and only one member of the range. So if a member of the domain has more than one member of the range, if it corresponds to more than one member of the range, it's a relation, but it's not a function. And of course, the domain is also your input. That's what you put into the function. And it's also called your independent variable because your domain can be anything for which the function is defined for. Now your range is also known as your output. So you input something into the function, you'll get something out of it, your output. And it's also called your dependent variable because it depends upon what you put in. That's what the value of the range depends on. So here we have an example of a function. You have your domain from -2 to 2. Well, -2 has a range value of just 5. -1 only corresponds to 8. 0 only corresponds to 6. 1 only corresponds to 6. And 2 only corresponds to 7. Since each member of the domain only corresponds to one member of the range, this would in fact be a function. And in a function, it's okay if the range corresponds to more than one member of the domain. It just wouldn't be one-to-one, which in a few lessons we'll talk about one-to-one functions and inverse functions. But as long as each member of the domain only has one member of the range, it's a function. Now, on the other hand, let's keep the same members of the range. Let's talk about a non-function. What numbers do we have for this one? Alright. They only give us 3, 4, and 5. Let's see what we got here. -2 only has a value of 3. Now, -1 has a value of both 3 and 4. 0 has a value of 4. One has a value of 5. And 2 has a value of 5. So you have your domain, again, from -2 to 2, and -2 has only one member of the range, being 3. But if you look at -1, it has two members of the range for both 3 and 4. And then 0 only has 4, 1 only has 5, 2 only has 5. Well, if you look at -1, it has two members of the range, which would make this not a function for the fact that if even one member of the domain has more than one value of the range, the whole thing's not a function, even if the rest of them have only one member. So that's something to keep in mind when trying to determine if a relation is a function. All right. Now, we also can algebraically determine if a relation's a function. So you have x squared plus y squared equals 4. A lot of you may know this from Algebra 2 when we did circles. This is the equation of a circle. So how would you determine if this is a function or not? Well, you want to solve for y. Y traditionally is your dependent variable, x is your independent variable, and usually y is a function of x. So that means y squared would equal 4 minus x squared. And of course, when we find when we solve quadratic equations, you get both a positive and a negative square root of the right side, so y would be equal to both plus and minus the square root of 4 minus x squared. Well, if we're looking at this here, for every value of x, no matter what value of x I put in, I'll have two values of y because you have both plus and minus the square root. So this is not a function for that reason, because no matter what value of x I put in, I'll have two values for my square root because it has both a plus and minus on it. Now, what if I had something like this? Y equals the square root of x squared minus 1. So we have y equals the square root of x squared minus 1. So it's just the positive square root. You don't see a plus and minus on it. No matter what value of x I put in, I'll have one and only one value of y. So this would be a function. This actually is a function in this case. And then, so let's see, we have 2x plus 3y equals 4. So is this a function? 2x plus 3y equals 4, the equation of a line. Well, solve for y. Let's go ahead and solve for y, get the y variable by itself. That would be 3y equals 4 minus 2x. So then y would equal 4/3 minus 2/3 x. And if you look at this, for every value of x I put in, I'll have one and only one value of y. So yes, this would in fact be a function. In the next lesson, we'll be graphing functions, and you'll get to graphically see what they look like. We'll talk about the vertical line test and all that stuff in the next lesson. All right, now how about y squared equals x squared minus 1? This would turn out to be the equation of a hyperbola, if we remember that from Algebra 2. But we want to solve for y. So y would equal both plus and minus the square root of x squared minus 1. Well, you have both a plus and minus on the square root, so for every value of x I put in, I'm going to have two values of y. So this would make this equation not a function. So this relation would not be considered a function because every value of x you put in, you'll have two values of y. Alright, y equals the absolute value of 4 minus x. So we have y equals the absolute value of 4 minus x. Is this a function? Well, for every value of x I put in, I'm going to have one and only one value of y. So this would be a function. This is the absolute value function. So yes, this is a function. One more like this. How about x equals negative 7? So vux hoi, x equals, you have a vertical line. We can apply the vertical line test to that, and it would definitely fail the vertical line test because it would cross through the entire thing. So this is definitely not a function. When x equals negative 7, it'll take on every single value of y, from negative infinity to infinity. So this is definitely not a function. All right. And of course we can evaluate functions. So we have f of t is equal to 3t plus 1. So t in this case would be your independent variable, that f of t, The function of t is your dependent, and it depends what values you put in. So let's evaluate f of 2. So that means you'll just put in 2 for the t, so that would be 3 times 2 plus 1, so that's going to equal 6 plus 1, which means f of 2 is going to equal 7. Now we can do the same with negative 4. F of negative 4, so take 3 times negative 4 plus 1, which would give you negative 12 plus 1, which should give you an answer of negative 11. And then, let's see, what if we put in f of t plus 2? So you can put algebraic expressions into the variable also. So f of t plus 2, that's going to equal 3 times the quantity of t plus 2, all that plus 1. That would equal 3t plus 6 plus 1, which would give you 3t plus 7. So f of t plus 2 would equal 3t plus 7. All right, let's see. We have q of t would equal 2t to the second power plus 3 all over t squared. So here's another function of t. Q of t equals 2t squared plus 3 all over t squared. So let's find q of 2. So put in 2 for t, you would get 2 times 2 squared plus 3 all over 2 squared, which would end up giving you 2 times 4 plus 3 all over 4, which would give you 8 plus 3 all over 4, which would mean q of 2 would equal 11/4. So q of 2 would give you a value of 11/4. Let's put in q of 0. Well, we should notice right away you'll have a 0 in the denominator. And a 0 in the denominator would make this whole expression undefined. You would just get 3 over 0, which would make this undefined. There's no solution in this case. So q of 0 is actually undefined. Now, what if I put in q of negative x? So I'll put in q of negative x. So put in negative x where you see the t. So this would be 2 times that negative x to the second power plus 3 all over negative x to the second power. Well, negative x raised to the second becomes positive x to the second. So this would end up being 2x to the second power plus 3 all over x to the second power. That would be your value for q of negative x. All right, then a little bit of review from Algebra 2. What if we had this? F of x equals 2x plus 5 from x is less than or equal to 0, or 2 minus x squared when x is greater than 0. So this is a piecewise function. So meaning, depending upon what part of the domain you're in, it behaves as two different functions. So when x has a value of less than or equal to 0, it's going to behave like the function f of x equals 2x plus 5. If x is greater than 0, it's going to behave like f of x equals 2 minus x squared. So let's put in f of negative 2. F of negative 2, so negative 2 is definitely less than 0, so this would behave like the 2x plus 5. So where you see the x, put in the negative 2, so this would be 2 times negative 2 plus 5. Well, that would give you negative 4 plus 5, which would just give you 1. So f of negative 2 would give you 1. If I put in f of 0, well, still, we have a provision for equal to 0. If x is less than or equal to 0, it'll behave like 2x plus 5. So this will be 2 times 0 plus 5, which would end up being 0 plus 5, which would be 5. So f of 0 would equal 5. And then let's see. Let's do f of 1. Now, this is where we have x is greater than 0. If x is greater than 0 and 1 is sure is greater than 0, we're going to use 2 minus x squared. So you'll put in the 1 for 2 minus x squared. So 2 minus 1 squared, well, that's just going to equal 2 minus 1, which would give you a value of 1. So f of 1 would equal 1. Let's do one more piecewise function, and then we'll move on again. F of x equals, we have a 3-piece this time. X plus 2 when x is less than 0. 4 when 0 is less than or equal to x, which is less than 2, or x squared plus 1 when x is greater than or equal to 2. So this is another piecewise function. So when x is less than 0, it'll behave like f of x equals x plus 2. When f of x, so when 0 is less than or equal to x, which is less than 2, it'll behave like f of x equals 4, which we know would be a straight horizontal line. Or if x is greater than or equal to 2, it would behave like f of x equals x squared plus 1. So let's take f of negative 2. F of negative 2, well, that falls under x is less than 0, so you'll put in negative 2 for your x, so you'll get negative 2 plus 2, which would be 0. So f of negative 2 would be 0. Let's put in f of 1. F of 1 comes between 0 and 2, so literally you're just going to get 4. F of 1 would be 4. Now let's put in f of 4. Well, 4 is definitely greater than 2, so you'll put the 4 in for the x and the x squared plus 1. So this will become 4 squared plus 1, which would equal 16 plus 1, which would be 17. So f of 4 would in fact be 17. All right. So we can also find real values for where the function equals 0. So let's say we have f of x equals 15 minus 3x. We want to find where f of x equals 0. So all you have to do is take the f of x, set it equal to 0. If you want to find where the value of the function itself equals 0, so that means you would substitute that 15 minus 3x in for the f of x. That would equal 0. then just solve for x. So you would get 3x equals 15, which would give you x equals 5. So when x equals 5, f of x would equal 0. Alright, f of x equals 5x plus 1. Again, we want to find where f of x equals 0. So let's figure out where f of x equals 0. So that means we're going to take that 5x plus 1, set that equal to 0, and we'll solve for x. So 5x would equal negative 1, which means x would equal negative 1/5. So when x equals negative 1/5, f of x would equal 0. All right. Now let's find where f of x equals g of x. So f of x equals, in this case, x squared. G of x equals x plus 2. So we need to find all values of x for where f of x equals g of x. So let's set f of x equal to g of x, which means we'll take that x squared, set it equal to x plus 2, which we want to solve for x, so you'll end up getting x squared minus x minus 2 equals 0. You just have a simple quadratic equation, which should factor pretty nicely into two linear factors. So you should get x plus 1 times the quantity of x minus 2, which would mean x would have to equal negative 1 and positive 2. So for the values of x equals negative 1 and positive 2, f of x would equal g of x. All right, f of x equals x squared plus 2x plus 1. G of x is equal to 7x minus 5. So f of x equals x squared plus 2x plus 1. G of x equals 7x minus 5. We want to find all real values of x where f of x equals g of x. So let's solve for those values of x where f of x equals g of x. So set that x squared plus 2x plus 1 equal to 7x minus 5, which we want to make the right-hand side equal to 0. So that should end up giving you x squared minus 5x plus 6 is equal to 0, which this should factor into the quantity of x minus 2 times the quantity of x minus 3 equals 0. So that should give you values of x equals 2 and x equals 3 for the values for which f of x equals g of x. All right, last topic is finding the domain of a function. So we want to find the domain. So let's say you have something like f of x equals 5x squared plus 2x minus 1. You have a simple polynomial function, right? A quadratic polynomial function. Are there any values of x which would make this function undefined? that would either give you an imaginary number or a denominator of 0 or anything like that. No. So the domain in this case is going to be all real numbers. You may either see it as negative infinity to infinity in interval notation, or you may also see the domain written as a double R like so. That also means the set of all real numbers. So we want to get used to seeing this R notation. A lot of your books will have that in the answer key. So the domain for this function is the set of all real numbers. Alright, h of t equals 4 over t. So we have the function h of t equals 4 over t. Whenever you have a fraction, especially a variable in the denominator, always set that denominator equal to 0. So take your t, set it equal to 0, which would give you an undefined value, right? You can't have a 0 in the denominator. So the domain, in this case, is all real numbers except t equal to 0. So that'll be from negative infinity to 0 non-inclusive, because we can't include 0, in union with 0 to infinity. It could literally be any real number except for 0. That would give us an undefined value in the denominator. Alright, f of x equals the cube root of x minus 4. So f of x equals the cube root of x minus 4. Well, what do we know about cube roots, or for that matter, any odd roots? The domain's all real numbers. You can take the cube root of a negative number, because you could take a negative number to the third power and get a negative number. That's why you could take the cube root of a negative number. So there's no values for which this function would be undefined. So the domain in this case is just going to be the set of all real numbers. Alright, here's a good one. We got two more. G of x equals 1 over x minus 3 over x plus 2. So g of x equals 1 over x minus 3 over x plus 2. Well, you have two fractions, both of them with variables in the denominator. So what you need to do, take each denominator, set it equal to 0. You'd have x equal to 0. Well, for this fraction, the first one, that would make your fraction undefined. So x definitely can't equal 0. Now take that x plus 2, set that equal to 0, which would give you that x equals negative 2. Well, if x equals negative 2 over here, that would give you a denominator of 0. So x also can't equal negative 2. X can't equal 0 or negative 2. So your domain is all real numbers except x equals 0 or negative 2. So the domain would go from negative infinity to negative 2 non-inclusive, in union with negative 2 non-inclusive to 0 non-inclusive. So it could take on any value from negative infinity up to negative 2, and then any value between negative 2 and 0, and then also again from 0 non-inclusive to positive infinity. So that was kind of a long domain. That was a very long domain. So domain is negative infinity to negative 2 non-inclusive, in union with negative 2 non-inclusive to 0 non-inclusive, in union with 0 non-inclusive to infinity. And I got one more. Alright, so we have g of y equals y plus 2 all over the square root of y minus 10. So g of y equals y plus 2 all over the square root of y minus 10. Well, let's look at the square root in general, right? The square root is only defined for positive values. So that means that y minus 10 would have to be greater than or equal to 0, right? So let's figure out where y minus 10 is greater than or equal to 0. That would have to mean y is greater than or equal to 10. Well, here's the problem, though. If we put in 10 in this case, you would get a denominator of 0, which we can't have. So y actually cannot equal 10. So therefore, your real domain is y is simply greater than 10. So the domain is going to just be from 10 non-inclusive to infinity. Because you can't have a denominator of 0. So the domain is from 10 non-inclusive to infinity. So that's a brief review of functions. Next lesson we're going to graph functions and we're going to do the vertical line test and all that. So I hope everyone has a great day. Take care.